Let's have a look at the distributive law. Let's say we have this expression here, 5 and then in brackets x minus 2. Now the first thing I need you to remember is that in algebra, if we haven't put an operation here, right, we haven't put a plus or a minus or whatever, what we mean is multiply. So what we've got here is 5 multiplied by this thing in brackets. And because 5 is multiplied by the brackets, what you've got to do is make sure that 5 multiplies with each and everything that is inside the brackets. And that's what the distributive law is. So when we go to multiply this out, we first have to multiply 5 with the x, and we get 5x, right? 5 times x, 5x. And then we're going to multiply the 5 with the 2, and there's still a minus sign, and 5 times 2 gives us 10. Let's do a slightly more complicated one. Here we've got negative 2x, and that must multiply with x minus 3. Now, one thing I really want you to do is to always be very careful and very aware when you see negatives, right? Put some big bright stars or something around them so that you remember to take note of the negative. And I'll show you why. Distributive law tells me exactly the same thing. I need to take this negative 2x and I need to multiply it with each and everything in that bracket. So I need to first of all multiply it with the x. Negative 2x multiplied by x is negative 2x times x is x squared. And then I need to multiply this with that. Now this is where that take note of the negative. What you've got here is you've got the negative and it's going to multiply with a negative, and so it is going to become positive. And then you've got 2 multiplied with 3, and you've got the x still. Over the next few lessons, we're going to be looking at reversing multiplying out. And today we're going to just start with thinking about the distributive law and seeing if we can fill in the bits that are missing. Let's go back to what we did with numbers. So way back when, you would have done stuff like what? 3 times 5 is equal to 15. So multiplying two numbers together can get you another number, right? 3 times 5 is 15. But at other points, you might be asked to split 15 up into factors. So you could then say, okay, well, I know that 15 is 3 multiplied by 5. And 3 and 5 are both factors of 15. There are other factors too, but 3 and 5 are factors. So what you've got here is multiplying out, and in this case it's kind of splitting it up into its factors. And exactly that process that you did with numbers, you can also do with algebra. So let me show you. Here is multiplying out when you're dealing with algebra. So we know that to multiply out here we use our distributive law. And so we get 3x plus 6. But we could equally well have been given 3x plus 6 to start with and be asked to factorize it. And in this case, we want to turn it into two things that are multiplied together. And in this case, it'll be 3 multiplied by x plus 2. So what we have are two processes, multiplying out, and then the reverse process of multiplying out, which is called factorizing. I'm now going to give you some examples where I give you one of the factors and you have to try and find the other. So for example, if I've got 10x plus 25y and it's equal to 5 multiplied by something, let's work out what that something is. Well, we know that we've got to do 5 multiplied by this and then 5 multiplied by that and end up with 10x plus 25y. So 5 multiplied by this first term has to give me 10x. We can think of it either saying 5 times what gives me 10x, and hopefully that's easy, 5 times 2x gives you 10x, or otherwise, because you know multiplication and division are related to each other, you could just say 10x divided by 5, which is 2x. And so you get your answer here of 2x. And then we also need to say 5 multiplied by this must give you plus 25y. Well, the first thing, we immediately know there's going to be a plus here. And 5 multiplied by what gives you 25y? It's going to be 5y. Could also have done it by saying 25y divided by 5, which is 5y. So here we have the factorized form. We have factorized this. Okay, let's see if we can figure out what number needs to go here. So what number, when you multiply it by 2x minus 5, is going to lead you to this answer? Well, 2x multiplied by what is going to get you to minus 4x? It's going to have to be a negative 2. And then let's just check that we do still get the plus 10. So negative 2 multiplied by negative 5 does give me plus 10. So we know we've got this right. And in the next one, we ask ourselves what multiplied by minus x is going to give you 3x as the answer. Well, there's obviously going to have to be a 3 in it, but 3 multiplied by negative x is going to give you negative 3x, and we want positive 3x, so we must put a negative with it. So negative times negative is positive. So let's just check by multiplying out. Negative 3 multiplied by negative x does give me 3x, and negative 3 multiplied by positive 3 does give me negative 9. So now let's look fully at how you factorize by taking out a common factor. So if you asked to factorize 8x plus 12, what you're going to do is have a look and see, is there a number that divides into 8x as well as into 12? Now obviously 2 will divide into 8 and also into 12, but that's not the highest common factor. You'll also have 4 that can divide into 8 and into 12, and that is the highest number that will divide into both of them. So 4 will be what you can take out, and now we just have to figure what goes in the bracket. So remember here, 4 times this must give me 8x, so this must be 2x, and then 4 times this must give me plus 12, so this must be plus 3. Now imagine you were asked to factorize 18y plus 24. You might be able to do it quite easily, but let's go and do it slowly just to show you a process. So we need to find the highest common factor of 18 and of 24. And if you can't immediately identify that, let me just recap with you how to find the highest common factor of two numbers. So we look at what are the factors of 18. And these will be 1 with 18, 2 times 9 gives me 18, 3 times 6 gives me 18, 4 doesn't divide into 18, 5 doesn't divide into 18, and then 6 does, but you've got it already, so you can stop there. Then let's also have a look at what the factors of 24 are. Same process. We start 1 multiplied by 24 gives me 24. Then we go to 2, and we'll get 2 times 12, 3 times 8, 4 times 6, 5 doesn't divide into 24, and then 6, well, you've already got it, so you can stop. Now all you need to do is have a look at these two lists of factors and see what is the biggest number that occurs in both the lists, and you can see hopefully quite easily that that is 6. So 6 is our highest common factor. So we're going to pull out a 6, and we'll see here that 18y divided by 6 is 3y, and 24 divided by 6 is 4, and it's a plus 4 because it's a plus 24. And if we want to just check, 6 times 3y is 18y, 6 times 4 is 24. We've got it right. If you are asked to factorize 10x minus 15xy, again what you've got to look for is the biggest thing that will divide into 10x as well as into minus 15xy. Number-wise, it's fairly easy, right? 5 divides into 10 and also into 15. But in this case, you also have an x that can divide into 10x as well as into 15xy. So x will be another part of what you take out. What's left in the brackets? Well, 5x times this must give you 10x, so this must be 2. And here, 5x multiplied by this must give you minus 15xy, so obviously what is here has to be minus 3y. Let's do a little recap on multiplying with exponents, because we're going to need these ideas to deal with factorization. So if we're faced with something like 3x cubed multiplied by 2x squared, the first thing we need to remember is that this is just everything multiplied together, right? This is 3 times x cubed, this is 2 times x squared. So we've just got all these things multiplied together. Now we want to work it out. We're going to say 3 multiplied by 2, that gives me 6. And then we're going to say x cubed multiplied by x squared. And x cubed means you've got 3 x's multiplied together. X squared means you've got 2 x's multiplied together. So in total, you'll have 5 x's multiplied together. So remember, our rule for exponents is if we're multiplying the numbers, we add the exponents. Okay, you try this one for yourself. Pause the video and try it. Alright, so hopefully you said negative 5 times 7, that gives you negative 35. And x to the 4 times x to the 6, well, you're going to have x to the 4 plus 6, so you're going to have x to the 10. And now we're going to get on to what we really want to do, which is what we're going to need when we're doing factorization, which is figuring out that missing piece. So we're asking here, 3x cubed times by what is going to get me to negative 18x to the 4? Well, hopefully it's fairly easy for you to see that 3 multiplied by 6 gives you 18, so it's going to be 3 times negative 6, which is going to get you to negative 18. And you could also have just done that by saying negative 18 divided by 3 gives you negative 6. And then if you're going to say x cubed multiplied by what gets you to x to the 4, well, hopefully that's easy for you to see that it's just x to the power of 1, which we write as x. But if you needed to work it out, you could also have done x to the 4 divided by x to the 3, and so you would get your answer of x to the 1. So the other thing we want to get practice in is finding the highest common factor of two terms. So if we're asked to find the highest common factor of 15p to the 4 Q9 and 20p to the 7 Q to the 5, what we're asking is, what's the largest thing that can divide into both of these two things? So we're going to deal with it bit by bit. We're first going to deal with the numbers. So highest common factor of 15 and 20, you should be very good at finding those highest common factors now. You know that that will be 5. And if you don't know how to do that, you need to go and do a recap of finding highest common factor of two numbers. Then if we've got p to the 4 and p to the 7, the greatest thing that can divide into both of those will be p to the 4. Because you can't make it any more than 4 p's because it wouldn't go into p to the 4. And p to the 4 divides into p to the 7 with no problem. What's the highest common factor of q to the 9 and q to the 5? Well, hopefully that's obvious to you. It's q to the 5. We're going to look at some more complicated examples where we're factorizing by taking out a common factor. If we're asked to factorize something like this, our first step is to find the highest common factor of these two terms. So let's start with the 8 and the 12. What's the biggest number that divides into 8 and also into 12? Well, that's 4. Then we look at the a's. Here you've got an a squared, here an a to the 6, so you need an a squared in the highest common factor. Here you've got a b cubed and a b, so you're just going to have a b in the highest common factor. And then here you've got a c, but here you've got no c's, so you can't put any c's in the highest common factor because then it won't divide into this term. Now we just need to figure out what goes in this bracket. This multiplied by this must get me to 8a squared b cubed. Well, 4 times 2 gets me to 8. A squared times what to get me to a squared? Well, it's just going to be a squared multiplied by 1. But we don't need to actually write the 1 in there because 2 times 1 just gives me 2. And then b multiplied by b squared will get me to b cubed. We then look at C4 times positive 3 will get us to plus 12. And then a squared multiplied by a to the 4 will get us to a to the 6. B multiplied by, it's just a 1 you need to multiply it by to get to b. And we don't need to write down the 1. We can if we want to, but 3a to the 4 multiplied by 1 is still just 3a to the 4. And then we need to put in the c. Remember, when you're doing these, it's also a very worthwhile effort once you've factorized just to quickly check by multiplying out that you do get back to this. So you just do a little quick check in your head by multiplying out. Okay, let's have a look at this one where we're asked to factorize this. Now in this case, actually, we can make a choice when we look at what's the highest common factor of -5 and 10. We could say that it is just 5, or we could say it's -5, and you can choose either of those. So for now, I'm going to actually choose -5. Then of x squared and x cubed, it's x squared, y to the 5 and y to the 7, it's y to the 5. Now I need to go ahead and work out what goes in the bracket. Well, it's -5 multiplied by what gets me to -5. Well, that's just a 1. And in this case, I am going to write down the 1 because I've got nothing else there. And so it's not like in this case where I had, 1 times 2 just got me to 2, so I didn't need to write in the 1. So let me put that 1 in. X squared multiplied by 1 gets me to x squared, but 1 times 1 is just 1, so I don't need to put another 1 in. And y to the 5 multiplied by 1 gets me to y to the 5. So again, I need another 1, but I don't need to write it down because 1 times 1 is still just 1. Now here, what -5 multiplied by what gets me to positive 10? Well, it's got to be a -2 to get me to positive 10. And then x squared multiplied by x will get me to x cubed, and y to the 5 multiplied by y squared will get me to y to the 7. And there's my answer. Now, as I said, I could also have chosen, and it would be equally right, 5x squared y to the 5 as my highest common factor. And so then what would I get? Well, I'm asking myself, this multiplied by this must get me back here. So 5 multiplied by -1 is what gets me back to -5. X squared multiplied by 1 gets me to x squared, and I don't need to write that down because -1 times 1 is just -1. And y to the 5 multiplied by 1 gets me to y to the 5. So I don't need to write that 1 down because -1 times 1 is just 1. And then if I look at the next, this multiplied by this must get me to that. So 5 multiplied by what gets me to 10? It's just going to be 5 multiplied by positive 2. And then x squared needs to be multiplied by x, and y to the 5 by y squared. And this should make sense. You've basically got the same thing here, but with the signs reversed, and that makes sense because the only thing that changed from here to here was the signs.